Moment of inertia of simple bodies. Now we are going to study how to find the moment of inertia of simple bodies. First, let us take a ring. Now we have a ring and we want to find the moment of inertia of this ring about an axis perpendicular to the plane of the ring. We want to find the moment of inertia of this ring about an axis which is perpendicular to the plane of the ring. We want to find the moment of inertia of the ring about the axis AB. Let the radius of the ring be R. Now if we divide the ring into small masses, let this mass be delta M1. Again we divide another mass, delta M2. Another mass over here, delta M3. Then all the masses are at a distance r from the center. Then moment of inertia of the ring about the axis AB is delta M1 into r square, because moment of inertia is mass into distance square, plus delta M2 into r square, and so on. Moment of inertia is mass into distance square from the axis. Here we take r square common. We have here delta M1 plus delta M2 plus dot 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 dot. When all these masses add up, it gives to the total mass of the ring M. M is the mass of the ring. So, my moment of inertia of the ring about an axis perpendicular to the plane of the ring passing through the center is m into r square, where m is the mass of the ring and r is the distance, r is the radius of the ring. Now if we extend this idea to a disk, we are going to find the moment of inertia of a disk. Say, here we have a disk of radius r, and we want to find the moment of inertia of this disk about an axis perpendicular to its plane and passing through the center. We want to find the moment of inertia of this disk about AB. Now in that case, we divide the disk into small rings. Since moment of inertia of the ring we know, we divide the disk into small rings. Let this radius be x, and the bigger ring has a radius x plus dx. dx is the thickness of this small strip of ring. Now moment of inertia of a ring is mr square, where m is the mass of the ring. So the moment of inertia of this ring will also be mass of the ring into distance square. Now how do we get the mass of this ring? Say, for unit mass or for unit area, we consider the mass as small m. Now what is the area of this strip? Area is pi x plus dx whole square minus pi x square, because the bigger radius is x plus dx. The bigger radius is x plus dx and the smaller radius is x of the ring. Now if we break this, it is pi x square plus 2 pi x dx plus pi dx square minus pi x square. Now pi x square cancels. Dx is very small, so square of a small quantity is almost equal to 0. So area, we are left with only this term 2 pi x dx. So to find the area of this ring for 2 pi x dx area, mass is m into 2 pi x dx. This is the mass of the ring. Now moment of inertia is mass of the ring into x square, since x is the radius. So the moment of inertia of the ring is mass of the ring, which is m into 2 pi x dx into x square. It is the moment of inertia of this black shaded ring. Now I want to find the moment of inertia of the disk. Then I have to integrate. I have to break this disk into small rings. small rings and add up the moment of inertia, which is done by integration. At the center, my x is equal to 0, and at the extreme end, my x is equal to r. My x changes from x equal to 0 to x equal to r. So to find the moment of inertia of the disk, I have to integrate this from x equal to 0 to x equal to r. So when we take the disk, this is my disk, x equal to 0 is my dot, and x was my distance of the string, and at this point my x becomes equal to r. So when I integrate from x equal to 0 to x equal to r, I have the integration over the full disk. So this is m into 2 pi. Here we have 1x. Here is an x square. X cube dx. The constant term is taken outside. 2 pi m integration x equal to 0 to x equal to r x cube dx. Now if we integrate this is equal to 2 pi m x cube. If we integrate x to the power 3 plus 1 divided by 3 plus 1 from x equal to 0 to x is equal to r. Therefore, moment of inertia of the disk about the axis AB, which is perpendicular to the plane of the disk, is 2 pi m x4 by 4 from x equal to 0 to x is equal to r. This 2 cancels. This is pi m by 2 upper limit r to the power 4 minus 0. Now the disk was of radius capital R. Unit area mass was m. This area is pi r square. So, area of the disk is pi r square into m, which is the mass of the disk. This is the mass of the disk. So this can be written as pi r square m into r square by 2. Pi r square m was the mass of the disk. It was the mass of the disk. Therefore, the moment of inertia of the disk becomes mr square by 2 about an axis. It is about an axis which is perpendicular to the plane of the disk. So moment of inertia of the disk about this axis was mr square, and of the ring, it was mr square by 2. It was mr square by 2. Now suppose this is z-axis and I ask you to find the moment of inertia about x-axis. So this is x-axis. About an axis passing through the center, I want the moment of inertia of the ring about this axis. The ring is rotating about this axis. In that case, we have to use the perpendicular axis theorem. We have to study two theorems. One is the perpendicular axis theorem, another is the parallel axis theorem. Now, what is this perpendicular axis theorem? Say this is a body, a lamina. This is my z-axis. Say this is my x-axis, or I'll consider this as my y-axis, and this is my x-axis. I consider a mass m over here at the point P. This P mass is at a distance x from the y-axis. It is at a distance x from the y-axis. So the moment of inertia about the y-axis is mass m into x square. Now this P mass is at a distance y from the x-axis. It is at a distance y from the x-axis. So Ix is m into y square. That is the moment of inertia about the x-axis. From the z-axis, let this distance be z. Now if we add Ix and Iy, Ix was m into y square. If we add the two, Ix plus Iy is m into x square plus y square. And x square plus y square, this is y. This is 90-degree angle between x and y. So x square plus y square is nothing but z square. So this can be written as m into z square, and z is the distance of this mass m from the z-axis. So this can be written as Iz Perpendicular axis theorem tells us that Iz can be obtained by Ix plus Iy. This is my perpendicular axis theorem. Now let us go back to the sum of the disk. Now we had a disk Now moment of inertia of the disk about this axis was mr square by 2. About this axis Iz was mr square by 2. Now our intention was to find the moment of inertia about the x or the y axis. So I want to find out about this axis. Now since this is in the plane, say this is y axis, this is x axis. Since it is symmetric, Ix is equal to Iy. And we know Iz is Ix plus Iy. Now let Ix equal to Iy be equal to I. Now Iz is mr square by 2. Put the value of Iz over here. Mr square by 2 is twice I. Therefore, moment of inertia about this axis I is mr square by 4. About the x or the y axis is mr square by 4 for a disk. Now suppose I ask you, what is the moment of inertia of this disk about this axis which is parallel to the z axis and passing through one edge? What is the moment of inertia about this axis CD? Now in this case, we have to use the parallel axis theorem, where h is the distance of the parallel axis from the known axis. So we will have to use a parallel axis theorem to find the moment of inertia of the disk about an axis CD which is parallel to AB. CD is parallel to AB. About AB, the moment of inertia is known. It is mr square by 2. Now in this case, we have to use the parallel axis theorem. So let us see what is the parallel axis theorem. Say we have a body here. This is an axis. Passing through the center of mass. And I want the moment of inertia of the body about an axis CD at a distance h from AB This is the center of mass of the body. I want to find the moment of inertia about CD, which is parallel to the axis passing through the center of mass. Now let us consider a mass m1 over here at a distance r1, mass m2 over here at a distance r2 from the center of mass axis, a mass m3 over here at a distance r3 from the center of mass axis. Now moment of inertia about CD is m1 into distance from CD. Now this one is r1 and this one is h. So distance of m1 from the CD axis is r1 plus h whole square, plus for m2 the distance will be m2 into r2 plus h whole square, plus dot 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 dot. For all the masses on the right hand side, the distance from CD will be r plus h, and for all the masses on the left hand side, the distance will be h minus r, because distance of m3 from this axis is h minus r3. This is r3 and this is h. So for all the masses on the left hand side, it will be h minus r. So ICD can be written as summation of all mi ri plus minus h whole square. Now h minus r whole square is equal to r minus h whole square. So we are writing here ri plus minus h whole square. Now this can be written as summation of mi ri square plus twice summation of mi ri h plus summation of mi h square. Now what is this mi ri square? R is the distance of the masses from the center of mass. So this can be written as I center of mass. So ICD can be written as I center of mass plus summation of mi ri is 0. Now why is it 0? m1 r1 is the moment about the center of mass axis. m2 r2 is again the moment about the center of mass axis. m3 r3 will give you the moment in the opposite direction. So mi ri is 0 since any body balances about the center of mass. So about the center of mass, net clockwise moment equal to net anti-clockwise moment. So summation mi ri is 0. So we are left with only the first and the last term. So this can be written as summation mi h square. So we can write this as this is equal to I center of mass plus summation of mi summation of mi into h square. The summation of mi is actually the total mass. So ICD can be written as I center of mass plus total mass into h square, where h is the distance of the axis from the center of mass axis. So we come back to the sum which we were trying to do. We were trying to find out the moment of inertia of the disk about the CD. Now this H is actually equal to R over here. So from the parallel axis theorem, ICD is I center of mass plus mass of the disk into h square. H is this distance. Now I center of mass is mr square by 2. Here h is r, radius of the disk. So moment of inertia about CD will be mr square plus 2mr square. So it becomes 3 by 2 mr square. So parallel axis theorem can be used to find the moment of inertia of a body parallel to the center of mass axis of a body. Now let us take another example. Say we are going to find the moment of inertia of a rod. To find the moment of inertia of a rod, thin rod of length L about an axis passing through the center perpendicular to it. So this point is minus L by 2. If this is the center, then this point is plus L by 2. I want to find the moment of inertia about this axis. I consider a small length here at a distance x. Let this thickness be dx. Unit length mass, let that be small m. So mass of this dx will be m into dx. Moment of inertia di of the small mass will be mass into distance square. And to get the moment of inertia of the full rod, I have to integrate this from x equal to 0, or if I take it from one end, this is x equal to minus L by 2 to x equal to plus L by 2. X is changing from minus L by 2 to plus L by 2. So this becomes mx square dx. Now if we integrate, this becomes mx cubed by 3 from minus L by 2 to plus L by 2. M by 3 upper limit L cubed by 8 minus of minus lower limit so this becomes m by 3 into 2L cubed by 8. 2 fours are 8. This is m into L square by 12. Now unit length mass was m. So total m into L is my total mass of the rod. So this can be written as I about moment of inertia of the rod about AB can be written as ml square by 12. Now suppose you are asked to find the moment of inertia of the rod about an axis passing through one end parallel to the center of mass axis. Then we apply the parallel axis theorem. This distance is h. H here is L by 2. So moment of inertia about CD is moment of inertia about the center of mass plus m into h square. I center of mass just now we got as ml square by 12. H here is L by 2. So this becomes ml square by 12 plus ml square by 4 ml square plus 3ml square. This is 4ml square by 12. So it becomes ml square by 3. So parallel axis theorem and perpendicular axis theorem can be applied to find the moment of inertia about an axis which is perpendicular or parallel to the center of mass axis.